Okay, number 2 is saying express the following complex numbers to polar form. Express the following complex numbers to their polar form. So we have Roman number 1, z is equal to 8 plus 6. So z is equal to 8 plus 6i. Okay, so to express it in polar form, we first need to get its magnitude or modulus. R is equal to is square root of a square plus b square, where a is 8 here, the real number. 8 square plus b, which is 6 square here. So this is going to give you a square root of 8 square. 8 square, which is 8 times 8, plus 6 square is going to give you 100 here, 100. So the square root of 100 is 10. So the modulus of these complex numbers is going to be 10 units. So now, since we got the modulus, so we need to get angle or theta. So theta is equal to tan inverse of b, which is 6 divided by 8. 6 divided by 8. So this is equal to tan inverse of, so if you simplify this one by 2, this is going to be 3 by 2, 4. It is going to be tan inverse of 3 divided by 4. So now press your calculator and see what is the value of theta. So when you are pressing this, you have to press shift first, then tan, then you say 3 divided by 4. So you'll get theta is equal to 36.87 degrees. So this is the value of theta. So since all of them are there, and you know the complex form of a complex number is z is equal to r outside bracket cos theta plus I sine theta. So since this one is a form of a complex number, you can now express this complex number 8 plus 6i is equal to r, which is what? Which is 10. 10 outside bracket cos of the angle, and the angle here is 36. The angle here is 36.87. Then plus I sine theta, and theta is the same as 36.87. So this is how you can express complex numbers in polar form. So this is the polar form of this complex number. For Roman number 2, we have z is equal to 3 minus 4i. So r of this complex number is going to be equal to square root of a square, which is 3, plus b square. So r is going to be equal to the square root of a, which is 3 square, plus negative 4 square. Negative 4 square, which is the modulus. R is equal to the square root of 3 square is 9, 4 square is 16. R is equal to the square root of 25, which is 5. So R for this complex number is 5 units. R is equal to 5 units. So what is the value of theta? Theta is equal to tan inverse of y out of x, or b out of a. So where we have tan inverse of b, the value of b here is negative 4 divided by 3. So what is the theta for this one here? So the value of theta is going to be equal to tan inverse of negative 4. Tan inverse of negative 4 divided by 3 is the same as negative 53. Negative 53. Negative 53.13. So this is the angle, negative 53.13. Now, since we have the two r, which is 5 units, and theta, which is 53.13 degrees, so we can now write it in Euler form. So, and Euler form of a complex number is z is equal to r cos theta plus I sin theta. So for this complex number, z is going to be equal to r, which is 5 outside bracket cos theta, which is negative negative 53.13 plus I sin theta, and theta is negative 53.13. So this is the polar form of this complex number. That is the polar form. Okay, good. Let us come to this complex number. So to express this complex number in polar form, so we have to say we need to first find r. The r of this complex number is equal to a square root of, or we can first rewrite this complex number. To rewrite this complex number as z is equal to negative 0.5 I out of 7 minus 44.9 out of 7. So what you have to know about this complex number, know that the first one here is the imaginary number, or imaginary part comes first. So they have brought imaginary number first, then followed by real number. So just know in your calculation, this one is A and this one is B. Okay, now that one is clear. So to get r, we will say r is equal to a square root of a square, and a square is this one here, this part. So it is that part, negative 4.9 out of 7 square plus b, which is negative 0.5 out of 7 square. So this is the r is equal to that one all. So let us try to now formulate this one. Negative 4.9 square divided by 7 square plus negative 0.5 square divided by 7 square. So when we formulate this one, it is going to be 0.495 under the square root. So r is going to be equal to the square root of that one. The square root of 0.495, so which is equal to 0.7. So this is the same as 0.7. So the value of r, or the modulus, is 0.7 here for this complex number. So now we need to find the angle of the complex number. The angle of complex number. So let's try to find the angle here. So we know angle, which is theta, is equal to tan inverse of b out of a. So the value of b is this one here, the imaginary number. So this is going to be negative 0.5 divided by 7. Then we divide this by negative 44.9 out of 7. So this is going to be the theta, the modulus of that complex number. So when we work this one out, so you will cancel 4. This 7 and this 7 will cancel, and this become this one here become the denominator. This become the denominator. It is going to be tan inverse of negative 0.5 divided by negative 4.9, which is going to be now you press it there in calculator, shift tan inverse of what, of 0.5 divided by 4.9. So this is going to give you 5.8. So you'll have 5.8 degrees. So this is going to be the angle. Angle is going to be 5.8 degrees, and R is already here, 0.7. So simply you can now express this complex number in polar form by writing Z is equal to R, which is 0.7 times cos of angle, and angle is 5, and angle is 5.8 plus I sine of 5.8, and this is it. So this is this one in polar form. So now you are done with it. That is how you can express them in polar form.